Imagine a machine, right, that could spot an absolutely tiny flaw on a circuit board, or maybe detect the very earliest signs of a medical condition from an X-ray. But here's the kicker. It doesn't just spot it. It tells you why it's a flaw, and maybe even suggests what to do next.
Yeah, that sounds pretty futuristic, doesn't it? But it's actually where AI is heading. It's moving beyond just, simple detection. We're talking about genuine understanding, even reasoning.
It's not just flagging problem here. It's acting more like a collaborator, explaining the context, suggesting next steps, just like a human expert would.
Exactly. That ability to reason and explain, that's what elevates it. It's a huge leap.
And that leap is precisely what we're digging into today. We're doing a deep dive into a really exciting new AI development called Anomaly-OneVision, Anomaly-OV for short.
Yep. And our mission really is to unpack how this system is shaking up two key areas. Zero-shot anomaly detection. That's the AI finding weird stuff it's never explicitly been trained on before, and reasoning.
So its ability to explain why something is unusual with almost human-like detail.
Exactly. And, this isn't just for the AI researchers out there. If you're curious about the future of making things, or medical diagnosis, or just, how AI is getting generally smarter, this dive will get you up to speed.
We want to give you that shortcut to understanding the breakthroughs, the really innovative stuff that lets AI see and explain.
And Anomaly-OV. It's being called the first specialist visual assistant for this specific, tricky area, built on totally new foundations.
Yeah, things like a unique way of looking at images, kind of a two-step process, we'll get into that, plus a novel training data set, and even a new way to measure how well it performs. It's pretty comprehensive.
Absolutely. But maybe before we jump into Anomaly-OV itself, it's worth taking a second to understand why this whole area, anomaly detection and reasoning, is so hard and so important.
Good point. So anomaly detection, AD, that's basically spotting things that don't fit the normal pattern, right? Like in factories checking parts or doctors looking at scans.
Precisely. Widely used. Think defect inspection on car parts, electronics, or medical image analysis, X-rays, MRIs, that sort of thing.
Okay, but the old way, unsupervised AD, had a major snag, didn't it? It needed tons and tons of normal examples to learn from.
A huge number, yeah, which is often incredibly impractical. Think about data privacy in medicine, for starters, or just the sheer effort and cost of getting specialists to label thousands of perfectly normal images. It's a massive barrier.
And even if they did flag something, those older methods,
Yeah.
they didn't really explain themselves, did they?
Not really. You'd get maybe a likelihood score, a number, but no why. No visual evidence pointing to the specific issue. And users, well, they need that rationale. They need to trust it, understand the root cause.
Right. Okay, so then along come these big multimodal large language models, MLLMs, things like GPT-4o, LLVA. They seem amazing at understanding images and text together. You'd think they'd nail this.
You would think so. They do have revolutionary reasoning skills for many vision tasks, that's true, but, and this is key, they have specific weaknesses when it comes to fine-grained anomaly detection and reasoning. The really detailed stuff.
Ah, okay. So they're good generalists, but maybe not specialists for this kind of task.
Kind of. The whole field of reasoning about image abnormalities is, surprisingly, quite underexplored, mostly because there haven't been good specialized datasets. So current MLLMs, they often cannot accurately detect and describe fine-grained anomalous details.
Can you give an example?
Sure. So GPT-4o might spot something wrong on a circuit board, but it might just say, anomalies in the board's design. Very general. A specialist needs the specifics. A short circuit, indicated by this white, crusty residue near the echo pin. See the difference?
Big difference. One is actionable, the other not so much.
Exactly. And the research points out something critical here. The information about the anomaly is actually there in the image data, in the visual tokens. The problem is the generalist MLLMs, they just cannot effectively pick out the related tokens. They aren't focused enough.
Which perfectly sets the stage for Anomaly-OV's approach, right? The specialist approach.
Precisely. Anomaly-OV is pitched as the first specialist visual assistant for zero-shot anomaly detection and reasoning. And its big idea isn't building a whole new giant model from scratch.
Which would be hugely expensive and time-consuming.
Right. Instead, it uses an auxiliary specialist or expert model. Think of it like a guide. It helps the main generalist MLLM to focus on the really crucial visual bits.
Like having a little expert on its shoulder, pointing things out. Look closer at this part.
That's a great way to put it. And it's clever because it avoids needing massive pre-training, but it still keeps the broad understanding, the generalization capacity of the original big model. It's efficient.
So how does this expert guide actually work? I think the paper called it Look Twice Feature Matching, LTFM.
Yes, LTFM. And the inspiration is literally how humans inspect things. You scan broadly first, right? Identify anything suspicious, that's the first look. Then you zero in, you inspect those suspicious areas closely for details. That's the look twice.
Okay, I get the analogy. How does it work in the AI?
Well, technically it starts with global object information from the image. Then, and this is a key innovation, it uses two learnable embeddings. Think of these as learned concepts or filters. One is E+ for anomalous patterns, the other E for normal patterns.
Okay, learnable filters for good and bad.
Sort of. They're merged with the global info to generate class awareness, abnormality, and normality descriptions. This makes the model sensitive to specific types of anomalies, not just a generic something's wrong. It's looking for, say, a poke on a capsule, not just an object.
That sounds much more useful for real-world inspection, more specific.
Definitely. Then it calculates these significance maps, basically heat maps showing how similar each part of the image, its visual token, is to those learned anomaly descriptions using cosine similarity.
So it highlights the bits that look most like the learned anomaly filter.
Exactly. And it averages these maps across different levels of the visual processing to catch anomalies at different scales. And here's a really neat part, academically speaking. This mechanism learns these object awareness abnormality embeddings directly in the feature space using only the visual encoder. Meaning it doesn't need a heavy text encoder during this phase, which many other zero-shot AD methods rely on. It makes the model potentially faster and more efficient. That's a significant technical contribution.
Got it. So LTFM finds the suspicious bits using just the visual side. What's next?
Next comes the visual token selector, or VT selector. Its job is basically to zoom in to aggregate the most crucial visual tokens identified by the LTFM.
So it takes the highlighted areas from the look twice part and really focuses the AI's attention.
Precisely. It helps the large language model, the LLM part, distinguish the important anomaly signals from all the background noise or irrelevant details.
How does it actually do the focusing?
It essentially uses those significance maps as a multiplier. It dims down the tokens that aren't significant, scaling them towards 0 while keeping the suspicious ones bright. So the LLM mainly sees the highlighted anomaly parts.
Okay, it filters out the noise.
Then it uses something called a Q-former module. Think of it as a smart aggregator. It takes all those highly correlated important visual tokens that were selected and summarizes them efficiently for the LLM.
So the LLM gets a clean, focused summary of just the suspicious visual evidence.
Exactly. This expert guidance ensures the LLM talks about the fine-grained details, not just vague descriptions. It's about precision.
And how does the final prediction come together?
Well, the actual anomaly score is calculated by combining information from different image patches, weighted by those significance maps. And when it generates the text explanation, it uses a clever indication prompt.
What's that?
It's a phrase like, with advin suspicious feature. Where advn changes based on the anomaly score, it could be highly, moderately, or slightly. This gives the LLM a hint about the confidence level as it generates the description.
That's smart. It connects the score to the explanation.
Yeah.
But, all this relies on having the right data to learn from, doesn't it? And you mentioned earlier that was a big problem.
A massive problem. The lack of multimodal data, specifically for instruction following in anomaly detection and reasoning, was a major bottleneck. Previous attempts, like something called Anomaly GPT, were quite limited in scale and how diverse their data was.
So how did Anomaly-OV tackle this? This sounds like where Anomaly Instruct 1 in 25K comes in.
Yes, this is a huge part of the innovation. Anomaly Instruct 1 in 25K is the first large-scale visual instruction tuning dataset built specifically for this task, and they had to get creative to build it.
How so?
Well, existing anomaly datasets usually don't have detailed text descriptions, and as we discussed, even GPT-4o struggles to describe fine-grained anomalies accurately without help.
Right, it needs guidance.
So the researchers developed this novel pipeline. First, humans manually combined the object class name and the anomaly type, like a capsule with poke on surface. They also drew bounding boxes on the images to pinpoint the anomaly location.
So they gave GPT-4o very specific hints.
Exactly. Armed with these hints, then they used GPT-4o to generate the detailed anomaly descriptions. And this process itself really proves their point. The visual information is there, but the MLLM needs that targeted input or specialized data to effectively pick out the related tokens.
That's fascinating. It shows the power of good instruction data.
Absolutely. And the dataset itself is incredibly diverse. It pulls from industrial sources like MVTech AD, medical data like BMAD, even 3D data, which they cleverly converted into multi-view 2D images. It creates this unified visual inspection dataset.
And there was another data component mentioned, WebAD.
Yes, WebAD, this is really important. It's an automatic pipeline they built to collect anomaly data from the web using GPT-4o and Google image search. This resulted in about 72,000 in the wild images.
72,000 from the web.
Yep. And this significantly enriches the data set. It's crucial because it lets the anomaly expert part of the model learn more general ideas of normal and abnormal without needing explicit text labels for everything. It helps massively with generalization, especially for that zero-shot detection capability.
That seems like a potential game changer for making this tech more accessible. Less reliance on perfectly curated, expensive data sets.
That's the hope. It could lower the barrier for using this kind of AI in specialized areas where getting lots of labeled data is hard or impossible.
Okay, so we have the innovative model architecture, the specialist guide, this massive new data set. But how do we actually know if it's better? Especially at the reasoning part.
Good question. That led them to create a new benchmark. VisA-D&R. They realized existing benchmarks didn't properly evaluate both detection and reasoning together.
So a new test was needed.
Exactly. It's built on a challenging industrial dataset called VisA, and they put in significant human effort to review and refine the descriptions, even ones generated by GPT-4o, to ensure the benchmark was really high quality, a gold standard.
And it measures more than just detection accuracy.
Oh, yes. For simple questions like, is there an anomaly? It uses standard metrics, accuracy, precision, recall, F1, but for reasoning, it gets more sophisticated.
How so?
They split reasoning into two levels. Low-level reasoning is about describing the visual defect itself, like yellowish discoloration. They evaluate this using things like Vishal, checking overlap with human descriptions, SentenceBERT, checking semantic similarity, and even GPT score, where GPT-4 judges the quality.
Using GPT-4 as a judge. Interesting.
And the second level.
That's complex reasoning.
Yeah.
This is where it gets really interesting for practical use. It's about providing potential causes or future improvement strategies, like explaining graffiti as vandalism and suggesting cleaning schedules. This is also evaluated with SBERT and GPT score. It's pushing towards AI that doesn't just spot problems but helps solve them.
That's a significant step up. So how did Anomaly-OV actually perform on these new benchmarks? The results are pretty striking. On the zero-shot anomaly detection side, its anomaly expert part showed significant image-level AROC improvements over the previous best methods like EdiClip and WinClip.
And AROC tells us how well it distinguishes normal from abnormal overall, right? Higher is better.
Correct. And they explicitly credit that large-scale in the wild online data, WebAD, for boosting this zero-shot performance. It really shows the value of diverse web-scale data, even if it's not perfectly labeled.
And what about the text explanation, the reasoning part?
There, too, Anomaly-OV showed significant improvement compared to other open-source generalist MLLMs. The examples really highlight this.
Like the circuit board one.
Exactly. Anomaly-OV identifies a short circuit on the PCB indicated by a white crusty residue near the echo pin. Super specific. GPT-4o, in comparison, might just say anomalies in the board's design, much less useful.
Or the macaroni example you mentioned.
Right. Anomaly-OV spots a subtle yellowish discoloration. General models often miss that entirely, or they might even hallucinate something wrong, like claiming the macaroni is cut in half.
So it's much more sensitive to subtle issues.
Yes, and that addresses a key weakness. Many existing MLLMs have much lower recall than precision, meaning they might be accurate when they find something, but they miss a lot of anomalies. They aren't sensitive enough. Anomaly-OV significantly improves that recall, that sensitivity.
Which is critical in high-stakes areas, obviously. You can't afford to miss things.
Absolutely. A missed crack in an engine part, a missed tumor. The consequences are huge. Higher sensitivity means higher reliability.
And it seems to work across different types of data, too. You mentioned it being a unified assistant.
Yeah, that's another impressive aspect. It shows good generalizability to 3D data and medical tasks as well. For instance, diagnosing pneumonia from a chest X-ray, describing the bilateral patchy opacities, and crucially suggesting the next step, consult a healthcare professional.
Moving into that advisory role.
Exactly. Or accurately spotting a bulge on the side of the bowl in a 3D model. even handling in-the-wild stuff, like identifying graffiti on a sign as vandalism and suggesting regular maintenance. That shows complex reasoning about cause and prevention.
Okay, this sounds incredibly promising. But no system is perfect, right? What are the limitations they acknowledged?
Right, and they're refreshingly open about them. There are still occasional misclassifications, like calling a candle a soap bar, or instances of hallucination in the reasoning, where it might invent details.
And sometimes the descriptions aren't quite as fine-grained as you'd ideally want.
Correct. It might sometimes default to a more general anomaly description, like just saying crack, instead of something more specific like wax missing on that candle example.
Sure.
For precise quality control, you'd want that finer detail.
Makes sense.
They also mentioned that the current design of the anomaly expert itself might be a potential bottleneck for pushing detection performance even higher. And, of course, the classic problem. Existing industrial datasets still have limited anomaly-type diversity. You can only learn what you see.
So plenty of room for future work then. What directions are they pointing towards?
Several key areas. Designing a stronger anomaly expert model is one. Exploring different base MLLMs, maybe other open source ones, could help with things like hallucination.
And data, presumably.
Always data. Creating more diverse industrial anomaly detection datasets is crucial. And technically, they're looking at integrating multi-level features from different layers of the visual encoder into the LLM.
Why is that important?
Because sometimes anomalies are really subtle, low-level visual cues hidden deep in the image processing layers. Feeding that richer, multi-level information to the language model might unlock even finer-grained understanding and detection.
Ah, okay. Getting more of the raw visual signal to the reasoning part.
Exactly. And finally, they call for more benchmarks in 3D and medical domains to properly evaluate these unified models as they get better and better.
So to wrap up our deep dive today, we've really seen how Anomaly-OV, with its clever look-twice approach and that huge new dataset, Anomaly Instruct 125K, is pushing the boundaries. It's moving AI from just seeing flaws to actually understanding and explaining them.
It's a significant shift towards more intelligent, more collaborative AI in visual inspection. The ability to reason about cause, effect, and even solutions is powerful.
It really makes you think, doesn't it? We've seen how this works for visual inspection. But the core idea, AI, that doesn't just detect but understands why, and maybe even suggests how to fix it. What other areas, what other tasks that rely on deep human expertise and nuanced judgment do you think are ready for this kind of specialized AI revolution?
That's the big question, isn't it? Where else can this specialist reasoning approach make a difference? It's definitely an exciting time to be watching this space.